This video, we're going to begin our discussion of arc length for vectored value functions. So consider a vectored value function that should have a arrow or bold. Consider a vectored value function given those parts, f, g, and h. We could call them x, y, and z if we wanted to, but they did f, g, and h in your book. So where f prime, g prime, and h prime are continuous, so this means there are no gaps. This makes sense. If I want to find the length of a curve, like the one to the right, hopefully there are no gaps in it because that would cause some issues. We also want it to be traversed once from A to B. What that means is I don't want to have a path that I go over 4 times between A and B because the arc length is going to be messed up. So the arc length is, this is something you guys did discuss in Calc 2. The formula for arc length, we need to put a DT here. This is my first write-up of a lot of these notes, so I will be fixing as I go along. For mistakes I missed when reviewing. Anyways, our arc length formula, if you guys don't remember, looks something like this in 2-space. It had that, and it's okay if you don't remember the exactly, but it was usually a formula. I know when I teach Calc 2, I give that formula, and it's one of those like memorize the formula, or you can put on a note card type thing when they were testing. Depends on what I did that semester. But I know a lot of teachers don't make you memorize this. Okay, this arc length formula does have the z component. If we didn't have the z component, we could do the same thing, just take out the h prime. So this is a nice, straight, easy formula. Find each part, plug it in, and figure it out. So an eagle rises at a rate of 96 vertical feet per minute on a helix, or I don't know how you say that, helical maybe, path given by the function there. So there's my path. As the eagle rises up in that path, it's flying in a circle where r is measured in feet and t is measured in minutes. How far does it travel in 6 minutes? Okay, so what that means, if I want to find this length, I just do 0 to 6. T is measured in minutes, so we didn't have to change that. Let's actually find each part first. So I'm going to move this down. We'll get to that in a moment. I have f of t or x of t. Actually, I'm going to use x. If you want to rewrite your formula using x to kind of stick with what we've been doing, please do so. If not, it's all arbitrary. You can use whatever you want. Okay, there's that. So I'm going to find x prime. X prime is equal to, okay, negative 20 sine t. Okay, y of t is equal to 20 sine of t, which means y prime of t is equal to 20 cosine t. And then we have one more here. Z of t is equal to 96t. And its rate, and this makes sense if you think about it, it raises 96 per minute. So the rate that it grows is 96. Okay, so we have all 3 parts there. I'm going to go ahead and do the integrand. I'm going to square each one. Just kind of doing all the work off to the side for a moment. All right, so we get 40 sine squared t plus, not 40, 400. Gotta cut that one. 400, and then 400 cosine squared, and then whatever 96 squared is. I'm going to leave 96 squared as, let's go ahead and multiply it out, actually. Grab my calculator. 96 squared is 9216. Notice that I can take out 400 of this part. And this is what we were wanting to happen. Sine squared plus cosine squared is equal to 1, leaving me with 400 plus 9216. So we add 400 to that. Okay, and that's what's going to go in the radical. I always check to see if it gets me a pretty number. It does not, so I'm going to leave it. It doesn't even break down further, I don't believe. So this is 9616. All right, and now I use the formula for arc length. L is equal from A to B, that's 0 to 6, so it's 6 minutes. And then all we have to do is throw in, it's the square root of what we just came up with, square root of 9616, which is a constant. So we get t times the square root of 9616 ran from t equals 0 to 6. So we get 6 times the square root of 9,616. That is my exact answer for the length that eagle, or the how much it will travel in 6 minutes going up like that if it were to continue going up. It's kind of neat. The formula is very nice once you plug everything in. That's why I recommended and why I worked it this way, where I went ahead and squared this out and then threw it in the square root, because it felt a lot less overwhelming to me doing that way. Used to, I would write it in there and do each line and rewrite it, and it just felt super overwhelming. All right, so that is arc length in 3 dimensions. It's not much different than in 2 dimensions. A lot of your problems will work out to be nice and pretty. If you get down to here and there are t's still inside of here, this is where it gets kind of gross. It gets really gross when we do that, because then we actually have to integrate something past this simple integration there.